Okay. Well, thanks for inviting me. I always enjoy meeting meeting people from other clubs and see what they're up to and giving a little talk. The topic tonight is low band antenna, low band receive antennas for all yards. We're going to talk about a number of different antennas. I'll start out by talking about what the low bands are and why you might want to operate them, some of the challenges of hearing on the low bands, and how receive antennas can help you. And hopefully we can find one that'll fit in your yard and your budget. Ron pretty much gave the bio there. I want to put in a plug for the NCJ, National Contest Journal. You guys are at all contesters. I've been writing that column for about 33, 34 years. And if you're an ARRL member, you can now go and download the online version every month for free. As you mentioned, I also run a little company called Unified Microsystems, which started out as a consulting company as a side gig around 1990. And a home project got out of control and ended up getting in the business of stuff. And right now, my biggest products are the low band receive antennas. Now, this is not going to be a commercial for my products, but I will talk a little bit about a few things that are kind of unique about some of them. So moving on, what are the low bands? Well, mostly they're considered between 160 and 40. Some people include 30 because 30 meters has a lot of the characteristics like 40. And they're popular antennas or popular bands because they're very reliable for short and regional communications. So you see a lot of nets, a lot of people have schedules and things like that if they're in range, because you pretty much know the band's going to be open, certainly during the day. If you're a contester, you need to cover them because there's a lot of contesting going on. And if you're a DXer, you're going to want to do it if you want to work the low bands in your 5-band DXCC or whatever. And we can get some pretty long distances, and especially during the low sunspot years. Now we're kind of coming out of that, but we'll still see a lot of activity here for a few more years. And the lower bands, especially like 160, are pretty challenging, but maybe that's part of the appeal. The big problem with these, the low bands, is noise. We have a lot of QRN, usually caused by thunderstorms, and you can have one of these things hundreds of thousands of miles away and pretty much destroy the band. Just static crashes are so loud. I mean, we can have there's like a hurricane going down the Gulf Coast. I can kind of much forget about work in Europe because it'll just be too noisy. And also because the skip distances are kind of short on these bands, you can hear a lot of the stations that you wouldn't hear, say, if you're on 15 or 20 or 10 even. There's a big pileup on some DX station. You may only hear a few of the guys calling, but there might be 50 guys calling. Well, if they're on 75 or 80 CW or on 60, you might hear everybody in the band calling them just about. And we got another big problem too with noise from digital electronic devices. And this is getting to be more and more of a problem as we get more and more of these electronic toys. You know, cell phone chargers are big problems. Plasma TVs have been terrible, although fortunately those are kind of being phased out. But another big problem looming on the horizon is these wireless chargers. Now, especially when they're talking about wireless charging at cars, where you just pull your car into your garage and it starts charging without plugging something in. You're transmitting tens of kilowatts of energy at you know, over the air essentially, and you get, you know, that kind of power and harmonics, and they'll change the frequencies to be efficient, and switching frequencies to be efficient, and you know, that can be a real problem. And I know the ARRL is looking into that because that could be a problem as they become more widespread. I just don't understand why would you want to use it wireless charging, is even, you know, lose 10 or 15% efficiency, you know, that's a lot of power, going to rack up your electric bill. That's not going to be useful. So how do you hear all the stations through that noise? Well, especially antennas that can be the answer. Now, some of these are pretty large and then have a reputation for that, especially like beverages, but there's some small ones that fit very small spaces. And a lot of different types available commercially, or you can make them yourself. There's a lot of good resources if you're looking at the particular details for design. The ARRL handbook is very good. Antenna book is good, and the ONU4UN low band DX, and it's got a lot of great information. There's a new book through the ARRL KL78J's receive antennas for radio amateurs. And of course, there's a lot of stuff on the internet. Now, the noise is kind of interesting on the low bands because usually the signals are pretty strong, but the noise is much larger. So you can hear a signal, it's S9, but if the noise is S9 plus 20, it's going to get buried. On the other hand, if you're on a quiet band, like say 10 meters, you have an S3 or S4 signal and the noise is like S0 or S1, that's a clear station. So we have some antennas that will help us get rid of that noise. Now, these antennas do not have gain like you'd consider a beam has, 5 or 8 dB a gain or whatever. But they do have directivity, but they're extremely inefficient. Some of them are only like 1% efficient, which is like a minus 20 dB loss. But they can also attenuate the signals much more than that in other directions. So even if you knock down your signal 10 dB, if you knock the noise down 15 dB, you might have improved the signal noise ratio, and it's all you need to make that contact. And these are effective if the noise is in a different direction than the direction of the desired signal. There's a lot of different types of low band antennas. We'll be talking about a few of the beverages, the larger loops and small magnetic loops. There's some other ones that are coming out. The vertical arrays are starting to get kind of popular. They're pretty expensive and they need to be set up properly, but they seem to have a lot of advantages. I don't know if you're familiar with the Waller flag. It's a huge horizontal loop type of an antenna, but they usually go up on towers over 100 feet and probably the size of a good sized monobander for 20. I mean, before I put up something that big, I'd probably improve my other antennas, but for some stations with the space and the pocketbooks, they can be pretty effective, but we won't be talking about those. We're talking about ones the more the average ham can probably put together. Well, the most popular, well-known antenna for low band is the beverage antenna. It was developed by Harold Beveridge. He was an engineer at GE. And so it's just a long wire pointing in the direction of interest with a terminating resistor at the far end and a feed line at the other. And it's best if these are several wavelengths long at the frequency of interest. This is what a drawing of a typical beverage. You see we have this long wire here. We have a terminating resistor to ground on one end and a transformer on the other end. It transforms the impedance of the antenna. It's around 470 ohms typically, down to 75 or 50 ohms for the coax. Now, the way these work is if you have a vertical signal coming in and it's traveling this way, what's going to happen is the part near the ground, the speed of light is lower. There's a lower velocity factor on the ground than it does in free space. So this wave will be tilted. It's kind of like the bottom of the wave is dragging its feet in the ground. And so now we have a tilted wave, and that travels along the length of the wire. And as it travels on the wire, it generates a current in the receive antenna. Gets to the end, goes to the transformer, creates a voltage, it goes back to our receiver, and we can hear that. Now, if the signal is coming from the other direction, it'll be the same thing. We'll have our tilted wave traveling down here, but now it sees a resistor to ground, so its impedance is matched, and it gets dissipated to the through the resistor, and we don't hear any signal from there. Now, these wires are often, hundreds or maybe even 1,000 feet long, and it takes a long wire to, and you're still only getting, maybe a 1 or 2% of the signal compared to another dipole or something. So the effect it's going to have coming at this direction against the wire that's, a fraction of an inch in diameter is going to be null. So it has some very deep nulls off the sides. Now, what if you didn't have the terminating resistor here? Well, of course, the signal would form the same way as it did before as it travels along here. But then it gets to the end, and well, it's got to go someplace. It can't just disappear. So the current reflected back in, and then back to the coax. So now it'd be bidirectional. And that might be of interest to some people. Like, for example, up here in Wisconsin, we have a beverage say to Europe, and we'll leave the terminating resistor on there so we don't hear any pesky W7s out of Arizona QRMing us, so we can hear our Europeans. But then in the morning, you maybe want to listen to the VKs or ZLs in the opposite direction. Well, if I were to take that, disconnect the resistor through some remote control relays or something, I'd be able to hear signals coming from the southwest. Now, at that time of the day, the sun is probably already rising in New England, so we're starting to building up the D layer, which is going to absorb their signal. So I probably won't hear them very much, and they really won't be a factor. So that's something that might be a consideration if you want to get a second direction, probably something out of a beverage antenna. Let's take a look at the pattern of a typical beverage. I've modeled this one as being 500 feet long, about 7 feet above the ground, and 470 ohm termination. This is a 30-degree plot. I did this with EasyNet. Now you see at 160 meters, we have a gain of minus 15, almost 16 dB, which is, it's almost 3 S units. Front to back's respectable, nearly about 20 dB. And we have a pretty wide beam with about 100 degrees to 3 dB points. Now, if we use that same antenna on 80 meters, we see that the front to back is pretty much the same. It hasn't changed too much, but we've got a lot more signal and the beam width's gotten narrow. Now we flip down to 40, we see the same sort of thing. We have even less, the signal's been stronger. Front to back still in the same neighborhood, but it's even narrower. So basically the longer the wire is, the more directive it's going to be for that particular frequency. Now the front to back you see right here with the 160 meters, you got one nice clean little lobe like that. We got to start going down to the higher frequencies. This will split up into a bunch of little spikes. So we might have some little points where it's, up around, minus, 15 dB or whatever. We may also have some nulls that are 20 or 30 dB. So it'll just kind of depend on what direction the signal is coming from. A few notes, we said longer is better, but at some point it really doesn't improve. A lot of people think 1,200 feet is probably a reasonable limit for 160 meters. You're not gonna really get a whole lot of additional benefit by going longer than that. And even a shorter one, 250 feet can be pretty helpful. Mine are around 350 feet and I'm pretty happy with them. Now you wanna try to keep them straight. You can do zigzags around trees and stuff, but if you're going off to the left a certain amount, then you want to come back to the right the same amount, so they kind of cancel each other. If your terrain is not level and mine slopes down and goes up and down a little bit, you want to follow the terrain. I don't, it's not perfect, but I try to follow it a little bit, and 7 feet is a pretty common height. That keeps it above people and deer, although I did have the deer take them out one time at 7 feet. It must have been one monster buck with a pretty good sized rack to be able to get it up there. But I was going for a walk one day and I found my wire strung across the nearby road, and I figured that had to be a deer. You want to keep them away from other metal objects, especially vertical ones, to prevent coupling of noise. Now, there's a lot of these rules here, but don't sweat it too much. Do what you can, and beverages just want to work. So if you can't make it perfect, it'll still work well. I mean, if you put it together, you'll get good results. An interesting thing, Jeff W8GNM gave a talk in August in the QSO Today conference, and he's done some experiments with making the wires zigzag up and down, or even in coils, to actually improve or make it electrically look longer, which is kind of an interesting thing. So the zigzag thing, it's in the vertical direction, is maybe not going to cause you problems with widening the beam width or picking up extra noise. Now, somebody's figured that, well, I can't put up a beverage, what if I just laid it on the ground? And actually, those are getting quite popular, called beverage on ground or bogs, when you just basically lay your wire on the ground. You don't want to bury it, and if it gets covered by dirt or snow, it's going to become less effective. And they're actually better if you can move it up a few inches. I know one guy who's got a fence in the direction that he wants to have it, so he's got it a few inches above the ground and noticed a real improvement as being above the ground. Actually, probably the best height for a beverage is around 3 feet, but it's not going to stay up very long if you got people or animals running around. So people put them up. There's a general rule that I've found is the higher they are, the more signal you'll get, but you'll also lose some of your directivity in front to back. But 7 feet isn't a bad compromise. Now, one of the advantages of beverages is because the velocity factor soil is less than free space, they can be actually shorter than an elevated beverage and still get the same sort of a pattern. So 90 or 250 feet are popular lengths, which is, on the short size for an elevated one. There was one thing I heard, I think it goes back to W3LPL, I thought said under normal ground, 220 feet or so is pretty much the optimal length for a bog at 160 meters. Now, a lot of that will depend on your soil. If you have dry soil, it'll be a lot better than if you have like seawater saturated soil, and then you may have to get a lot shorter than that if you have that kind of soil. I suspect that's not a problem there in Phoenix. Another advantage of the bog, you don't require supports, because so it's potentially something you might be able to put up with. The neighbor is not going to complain. The impedance is different. It's around 270 ohms. So you have to change the impedance in your impedance transformer. The big disadvantage, I think, of the bogs is that the signals are about 10, 15, 20 dB below a similar beverage. So you might need a preamp if you're using a bog. There's a number of loop antennas that are popular. Here's a few of them. And these work on a completely different principle than like the beverage. They're more like closely spaced phase verticals. K9AY array is very popular. It was developed by a guy who lives not too far from here, about 80 miles or so, Gary K9AY. And it's 2 diamond-shaped loops at right angles, and he had some switching, so you can instantly switch in 4 directions. It's very nice because it doesn't take up a whole lot of space, about a 25 by 25 foot space, and a support about 25 feet will do the job. And if you hang it from a branch, it can be kind of hard to see. There's a local guy here who saw my K9AY array, and he said, I want to make one of those, but his wife told him that no more antennas. Well, he had a tree out in the back, and there was some shrubs and stuff around, and he hung it up in the tree, and 5 years later, she still hasn't noticed that it's there. Here's a picture of it. Basically, this diamond shape. We got a terminating resistor to ground and a transformer to ground. Now, as you remember on the beverage, if we set the transformer and looked to the direction of the terminating resistor, that's where the signal that we're going to be looking for. This works the opposite direction. So the null direction is not a completely different direction. This is the one I have at W9XT. It's a little bit hard to see. It's got a PVC mast around 24, 25 feet. This is the northeast leg, which you can kind of see. Southwest leg goes the opposite direction, and there's down this way southeast, and you can't really see you really can't see the one going to the northwest. And I feed this with RG6 75 ohm TV cable. We'll talk a little bit more about that. I've never felt a need for a preamp, and it's really nice because it covers all 4 directions in a pretty small space. This is the switching and impedance transformer part that for mine, and it's in a little box I bought at one of the big box home improvement places. We have our relays for switching. Here's a transformer. This is a gas discharge tube. This thing helps protect the transformers. I don't get on the low bends much during the summer, and almost every fall I would check it out and it would be dead. I couldn't hear anything on my beverages or my K9AY array, and I'd look inside and everything looked fine, no damage or anything. I'd replace the transformer and it worked again fine. So something killed the ferrite material, probably some electrical surge or something like that. Ever since I started putting a gas discharge tube, I have not lost a single one, and these have been up for years and years and years. And I also put them in my commercial products just to added protection. On the side here, you'll see a little board there that I designed to try out. And like I said, the normal impedance is around 470 ohms. Well, I put in a bunch of resistors and some switching so I could essentially remotely change the termination resistance. And what that would do is it would change kind of the angle of the reverse side null. I could move that up or down. And if the noise I was trying to null was exactly off the back, I could sometimes reduce it by about 2 S units, but it's only if it was directly behind, and it's a lot of messing around, and I'm no longer using that. But if you really want to get the maximum performance out of it, you might consider putting a variable load on for your termination. This is a schematic that I have for my switching. And this has a number of changes from the original K9AY design. The original article, if you look it up, it's got a transformer that's tapped, a single transformer, like an auto transformer. It's tapped at the 75 ohm line. And pretty much everyone's gone away from that to a binocular core with isolated primary and secondary, because it really cuts down the noise picked up. So pretty much everybody's building them that way. And of course, I added the gas discharge tube as well. Gary's design would feed power through the coax for switching. You'd have plus voltage to turn on one relay, minus 12 volts to turn on the other relay, or AC to turn them both on. I've had problems feeding power through the feed line, and sometimes just entered a lot of extra noise. And so I've stayed away from that. And I think if I'm running a piece of coax out there and burying it, I might as well just I use some direct bury Cat 5 cable, which is fairly inexpensive, and just ran that out there at the same time, and then switch it so I don't have to worry about any noise pickup. And if you want some more details, you can look at W9XT.com and you can see some more information on my K9AY arrays. Some other popular loop type antennas are the flag or the pennant. These are a little bit larger, and this horizontally wise anyway, require more supports. They have pretty broad. The other versions, the EWE or U, and the V3DO, which is kind of a modified V3DO. Instead of using the ground like to close the loop, it basically just uses wires and keeps them about a foot or so off the ground, and you can actually use the same ground rod here. And the impedance of these loop antennas is about 1,000 ohms. Now, if you really don't have much space, there's the small magnetic loops. These are 3 or 4 feet in diameter typically. They can be square. You can buy them commercially or build your own. I don't have a lot of experience with this, but I know some people with some very small yards, and they said they've helped. It's not going to be as good as an 800-foot beverage, but it's probably better than your transmit antenna, and especially have a vertical in most cases. Now, they do require a preamp because there's not much of signal. Now, these are bidirectional, so if you're looking at it from the top, you're going to be null, looking through the loop, so they'll be off the edges that you'll be receiving. And a lot of times people use these things not really to peak the signal they want to hear, but to null out an offending RFI source. So if you've got a neighbor, who's got, say, a plasma TV, and you might be able to use this to null him out, but of course you're not going to help trying to receive anybody in that direction, or else 180 degrees. Now, one of the problems with beverages and some of these bigger loops is you can't rotate them. And then, okay, you put your one to Europe or maybe to Japan, but sometimes it'd be nice to get different directions. There are some designs out there for beverages and bogs that use 2 wires and multiple transformers. There's some commercial ones, and you can and you can make your own. I built one years and years ago. I wasn't very happy, and I went to a single wire beverage after that. Was much happier, and maybe I didn't build it right or something, but that was my experience. But apparently some people have some good luck with them. So now Jeff, W8GNM, came up with an interesting design called the BevFlex. And it's very interesting because it uses RG6 coax as the antenna element, say for a beverage. And you can switch forward in direction, and you can feed it at any point. Like the beverage, you have to feed at one point. With the BevFlex, you can feed it anywhere along that line. And it can also be configured as 2 direction for flags, EWE or V3DO type loops. Well, he came to me about 2 years ago and asked me if I would be interested in making them. He had some other companies build them. One of them decided to get out of the ham business. Another one was, they made very nice beams and stuff, but they really weren't very good at doing things with circuit boards and in boxes and stuff, and they weren't able to keep up with demand. So he came to me. My career professionally, besides doing design, I've also been highly involved in electronic manufacturing, contract manufacturer, and also running a production department at one place. So anyway, we talked for a while. I'm actually making these things now, and I sell them. You can get them on my website, and they're also available from DX Engineering and Ham Radio Outlet. But his design is quite interesting. Here's kind of the thing you use for a beverage or a bog. These are the pictures of the actual elements. You have terminating units at each end and the feed unit somewhere in the middle. This can go anywhere along here. So normally you'd put this nearest the house. And you have RG6 coax. And so what happens is your signal is coming along just like a normal beverage pattern. It gets tilted and goes along here. And it builds up a current on the outside of the RG6 coax. And the terminator actually takes that signal and then converts it to 75 ohms and injects it back into the coax center. So the coax is actually working as 2 ways. The outside is the antenna, and the inside is a regular type of feed line. And the feed unit just takes that signal, splits it off, and sends it back to your shack. And of course, it's symmetrical, so we have another signal from the other direction comes back to the shack. And the switcher control unit selects which ones you want to use, and it terminates the other unused ones so the signal doesn't go back out and bounce around and mess out your pattern. It's a very, very clever design. And he can also make it as a loop, different type of loop configurations, and the same sort of thing on using wire here. But it's a very flexible antenna system. If you're interested in experimenting, you want to try it. It works as a beverage bog or 3 different types of loops, and there's different jumpers and stuff that you set in the terminators to make sure you're using the correct impedance transformations. So let's take a look at some other considerations when you want to put up a low noise receive antenna. Maybe the most important is you want to protect your receiver. If you've got a rig with a separate receiver input, then you feed your beverages or whatever to that. If you're running, especially running high power, you can burn out the front end of that receiver, especially if you're running a kilowatt or if the antennas are close together. So the first thing you want to do is try to keep the antennas as far apart as possible. You may want to use a protection device. There's some that will just basically disconnect the receive antenna or the antenna from the receive jack during transmit. There's some RF limiter type things. The BevFlex has some back-to-back diodes, which will kind of clip off some of the signals and give you a little bit of additional protection. And of course, you always want to disconnect the antennas when there's a thunderstorm possible. You want to keep them away from other metal objects because they can inject a lot of noise, especially vertical antennas. If you're putting up a beverage or whatever, avoid putting over radios for your transmit antenna if you're using a vertical radios. You may want to consider detuning the transmit antenna. And some people do that just to keep from messing up your padding and reduce some of the coupling. It's pretty amazing. You know, the wavelengths here are on these bands are pretty large. And if you know, it's not practical for most of us to be several wavelengths away in 160 meters, but they can have a large effect. One of the local radio clubs had a talk a couple of years ago by there's a guy who did consulting broadcast engineering work, and he was showing a job that he had out in New Jersey. And AM broadcast stations are required to verify their pattern. They usually have special patterns that for their coverage, so they aren't, going into areas that that's covered by their stations in the same frequency. Or, if you're near side of the ocean, there's no point in wasting your power transfer over the ocean. You want to do it over the land where your listeners are. And he was doing a survey that they'd have to do every year in this one. They found that the pattern was messed out, and it turned out that there was a cell tower that had gone up in the last year about a mile or two away, and that was disrupting the pattern enough they were violating their license, so they had to correct that. And he was showing how all these things they had to do to detune that cell tower. It's quite interesting, but it was amazing that distance had that much effect. But this is ham radio, and it doesn't have to be perfect. So you do the best you can, and you probably, you're probably going to see an improvement no matter what. But so try to do the best you can, but don't become a slave to it, or even worse, don't decide not to do it because you can't do it very well. Oh, I'm getting the thing that's unstable. Hopefully you're hearing me okay. Most of the systems today are using 75 RG6 coax. It's cheap, it's low loss. You can get some types that are self-sealing. So if you have rodents and they decide they want to chew on it, it'll seal itself up as long as it doesn't cut through the braid. There's a couple of different pattern types. There's dual and quad shield. The dual stuff is probably what you might have in your garage from way back when, but the cable companies aren't able to meet the FCC cable emissions leakage specs with the dual shields. They went with the quad shield now. So you have a metallized mylar, then braid, another metallized mylar, then another braid on top of that, and you can get about 15 dB more shielding with the quad shield. It's not much more expensive than the dual shield because the stuff's made in such large quantities. So if I had to go buy some, I always buy the quad. If I had some dual stuff laying around, was in good shape, I'd probably use that. But it's important to get the right connectors. If you try to use quad shield with the duals, it just isn't going to make a good connection. And they have some connectors that have designed for outdoor use with gaskets in them, which helps. They're a bit hard to find though. And whatever you do, you always want to waterproof the connections like you would any other coaxial connection. Do you need a preamp? Most of the time you don't. I've very rarely had the need for a preamp with my systems. If you have an older rig, maybe you could use electric gain. If you have really, really long coax runs, maybe. Some radios, like I have an FTDX 5000, have an extra preamp you can put online. Now this is designed for 10 and 6 meters, where it's very, very quiet. And normally on the low band, you definitely want that off. And in fact, you talk to guys like Rob Sherwood, they'll say you should always put attenuation in anyway. But if you have an antenna like a very small loop or maybe a short bog, you might find that preamp in there will help a little bit. But if you are using some of those type of antennas like the small magnetic loops, you almost certainly need a preamp. Now, one thing that can kill the effectiveness of a low band receiver is common mode noise. Now, normally in a transmission line, you have a current flowing through the center conductor in one direction, and you have an equal current in the opposite direction flowing on the inside of the shield. But sometimes you get a situation, it's called common mode, where you'll have the current flowing on the inside and usually the outside of the coax at the same time in the same direction. And that can generate noise which will be coupled into your receiver. There used to be a YouTube video, a guy was showing on the spectrum analyzer what he saw until he put some fixes on. Unfortunately, I was not able to find that. It must have been taken down, but in some cases that noise can be very dramatic and actually pretty much ruin the effectiveness of your receive antenna. And there's some solutions. Burying your feed line back to the shack seems to help. Putting chokes or ferrite beads on the outside of the coax, or wrapping the coax around the core about the point where it enters the house, or even next to the rig, will often help a lot. One-to-one isolation transformers can help. I put isolation transformers in the switching unit for the BevFlex. And as I mentioned before, if you feed power on the coax to power a preamper to do the switching, that could potentially be a problem. So it can be done, but if it can also be a problem. So just kind of a word of warning there. So conclusions, these antennas can help you a lot. Some of them don't require a lot of space, although, you know, generally performance will be better on the bigger ones. You can buy them or build them. You know, like I said, there's a lot of things to be careful about, but just try to do the best you can and just put one up. You'll find that these things are almost always better than your transmit antenna for receiving. And having multiple ones is a big help. You'll find on some nights that one will be better than the other. The beverage I have to Europe is almost always best to Europe, but every once in a while I get a night where the K9AY outperforms the beverage to Europe. And just a quick showing how the W9XT antenna systems work. Here's the house. I have a tower 1 here and tower 2. Most of the lower band stuff is on tower 2. I have a beverage going to the northeast, about 350 feet. I have a BevFlex bog about 300 feet or so going northeast southwest. K9AY array is here. I have a northeast southwest BevFlex is a bog. This is the first one I put on when I was trying to decide whether these things worked enough that I wanted to get in the business. And so I put one up so I could compare it to the beverage. And I was kind of convinced that was at the time the VP9D to Pitcairn operation was going on. And I worked them on 160 meters CW. I was never able to hear them on any other antenna but this one. And that was pretty much the thing that sealed the deal on me. It really helped. I've done my own switching systems. I have some switches which I also sell. They're designed for low band use. I have one down here for switching these, and I have another one in the shack. And I built the controller here. The way I've got it set up, if I set the direction, it'll switch both these antennas and the K9AY in the same direction. Now, normally I find the beverages are best when I'm DXing, but if I'm contesting and calling CQ from here in Wisconsin, most of the time I'll be working guys east of me, southeast, or maybe, you know, northeast. And if I'm using the beverage, I'll certainly be able to hear them okay. But if I hear somebody say from Arizona calling me, I probably won't hear them on the beverage. But in the K9AY array, it's not quite as directive and it's a little bit broader. So I can usually hear the signal in there. I may not be able to copy the call, but if I start flipping the directions, I can peek them and at least know which direction is the right one. If I can copy them on the K9AY array, great. If not, I can flip to the beverage and it's already going to be pointing in the right direction, and almost always that picks them up. So it's a pretty efficient system that I have here. I'm pretty happy. I'm doing some changes. It was down there, and over the summer we had a few trees fall down and take out my beverage to the northeast, and I was planning on converting that to a BevFlex so I can get the southwest on there. This is a bog, and I plan on raising that if I can get some. I use PVC pipe for the supports on my raised antennas, but that stuff's just about impossible to get these days and very expensive when it is. So that may have to wait till the supply chain thing happens. I'm going to probably take this one around and then put it east and west, because I'm finding them in Africa sometimes it's just not quite picking up on any of my antennas. It's kind of a dead zone east and west, and so help me pick up the to the east and to the west. So that's it. If anybody have any questions, I'd be happy to answer them.
Very interesting. Yeah, don't everybody speak at once.
So how high above the ground is your beverage?
They're about 7 feet.
What
And
about
that's-
your bog?
The bog's right on the ground. The 7
I mean,
feet is for
Just
is
running
deer.
on the ground, on the
Just
ground?
right on the ground, yeah. It's actually kind of grown into the grass, and I got to pull it up, and it's best to pull it out of the grass every year.
What is the attenuation from the bog compared to the beverage?
Typically, the bog will be about 15 dB lower than a equivalent beverage.
Do you have a preamplifier in your case?
I just used the one that's built in my radio. My radio has got a preamp it's really designed for 6 meters. You don't normally want to use it in the low bands, but if you have an antenna like this bog, which is very low, I found that works out well enough for me. Some people, there are preamps available. If you are looking for a preamp, I would suggest you look. Two things to look for is a high dynamic range. That spec is usually not published. And if you got one that's got variable gain, that's probably a good idea too. It's very easy to overload your receiver on the lower bands if you aren't careful.
So I understood that you may sell those antennas. You have a business.
Yes.
So do you sell? Which ones do you sell?
Well, I sell the Bevflex systems. I also have transformers and terminators for regular beverages, and you can get on my website www.unifiedmicro.com. They're also available from DX Engineering, and HRO also sells them too. If you go to actually DX Engineering as well as my website, there'll be links to the manuals, so you can read about how to use them and things. All the details are there too.
Thank you. Appreciate it, Gary. Thanks.
Gary, there wasn't much conversation about magnetic loops. I've been using a magnetic loop for many years now, and a K9AY. And different days, different times, one works better than the other. But the magnetic loop, mine's a big one. I'm about maxed out. It's 9 feet in diameter, but you can put it on a rotor. And that's what I do, and rotate it around, either null out the noise or peak up the signal. And it's been very effective. And that uses 1/2-inch hardline coax. And so it's rigid, and you tie it to a pole and put the pole in the rotor, sink the rotor in on a peg on the ground. And it really is great for peaking up whatever you're after. No preamps. I use the preamp in the rig, which you get up to as much as 20 dB gain. I generally don't need that. And actually output from the magnetic loop is a little bit higher than in general than the K9AY.
That's interesting. I'm sure the hardline helps. It gives you a really good shielding compared to maybe regular coax or whatever.
Yes, right. And one of the reasons for the hardline, of course, is that the whole thing is rigid and flop around, and so it's circular, and it's been very good. I got the design out of and I can't think of his call in California, who is big on magnetic loops, and homebrewed it, and it's been very effective.
Excellent. Yeah, I've never gotten around to trying, just too many things and the lack of time to try everything I want to try. It's always good to hear what the results are in their experiments. That's great.
It's been the K9AY works great on 80, and I'm a 160 guy. I got a little over 200 countries on 160 using those antennas, but you need them both. Sometimes one outperforms the other one. You just never know.
Yeah, it's really strange. My first QTH, or last QTH rather, it was too small of a yard to put up thing, and I actually made, we didn't know what they were called bogs those days, but I just laid out a piece of wire on the ground about 80 feet, and it was laid right on the ground. I used some thin wire. I just put it out in the fall, and put it into fed it against the ground rod. There was no termination, no transformer. I did need a preamp, but there was times that antenna outheard everything else, and there's times maybe my 80-meter dipole was best on 160. It's, 160 especially is a very strange band, and I don't think anybody really understands it, but having a lot of options, is not a bad thing to receive on the low bands.
Yeah, 160 is a challenge. Very good pitch. Enjoyed it very much.
Thank you.